Hello, this is my 6th video on spacetime diagram, and today we're going to be talking about simultaneity. So actually, I think this is one of the concepts that spacetime diagrams make really intuitive. So simultaneity is when two events occur at the same time. But from what we learned before spacetime diagrams, we learned that just because two events happen at the same time in one frame, it doesn't mean that it also happens at the same time simultaneously on a different, for example, moving frame. And so we're going to be showing that with the spacetime diagram. So we have two events. Event A and event B. Let's first look at where these event A and B happen when we're looking at these events from a moving frames perspective. And when we're looking at events from a moving frames perspective, we're going to use these two axes over here. And simultaneity is always talking about time. So we're only going to look at this CT primed axis here. Okay? So what you're going to do is you're going to get a ruler. You're going to angle it so it has the same angle as your x primed. And that's going to be your grid lines, right? And you're going to move your ruler. Oh, this image is from the Tsoko's textbook, actually, and it's already done for us. And so we can see that to find the time prime coordinate of event B, just draw a line from event B to the CT primed axis. So we get here. Let's call this TB prime. What about A? We do the same thing for A. You draw a line from event A, the point A, to the CT primed axes. You find the intersection. Let's call this TA primed. Now we can see that, now we can see here TA primed is not equal to TB primed. Matter of fact, we can see that from the move, TB primed happens a lot earlier than TA primed. So we can conclude that in this moving frames perspective, event B happens first, and then time passes, and then event A happens. Okay, that's pretty straightforward. Now, what about if we're looking at the stationary frames perspective? Let me use a different pen, a blue pen here. What you're going to do now is you're going to angle your ruler so it has the same angle as your x-axis, not x primed, just the x-axis. Whatever. Okay, that's about the same. And you're gonna extend a line from from event B, draw a nice horizontal line from dot B to the CT axis. Again, we're looking at the stationary frames perspective here. Let's call this TB, not TB primed, because again, it's stationary frames perspective. What about A? You do the same thing for A. I'll use a different pen just for clarity. You draw a line from A to the CT axis, a nice horizontal line, and again, you get TA. Now from our lines, we can tell that TA equals TB. Therefore, I'm just going to write it out so that it's extra clear for you guys. Therefore, event A and event B are simultaneous in the stationary frame. Why? Because TB equals TA. But event A and event B are not simultaneous in the moving reference frame. Why? Because TB primed is not equal to TB primed is not equal to TA primed. And that's it. That's that's everything about simultaneity. I think it's a lot clearer than, it's a lot more straightforward than time dilation or length contraction. If you want more clarifications on different aspects of the space-time diagram, then feel free to leave a comment.